Welcome to this video. In this video, we are going to do the task that is very important as a data scientist, which is to select an important numerical features using correlation. Now, first of all, what are the features? So features are nothing but these are target variables. See here, these are all the features. So we have in fact 32 features. I can just give the color. So these are our features, like first is a hotel is the feature, is cancelled is next feature, and this is next feature, and so on. So we have 32 features, and here these things are observation. They are called observation, like these informations. Right here we have these information, they are called observation, and at the top we have these features. Now in our case we have in fact 32 features, 32 known features that we have in our program. Now if we are making any machine learning model using all of these features, then our machine learning algorithm might not be fruitful. Our machine learning algorithm might not work properly because some of the attributes might be meaningless, and some of the attributes will hinder our machine learning algorithm to converge or to get better result. So that is the reason we need to find the important feature for any algorithm, and we can only use that feature and just remove all the remaining unimportant and useless features. So that is what we are going to do in this video. So in our case, if we go to our data, we have 32 features, and we have already seen it at the top. If we go at the top, we have seen here we have these many attributes, which are, if you count, they are 32 in numbers, and we don't want all of them. We have to remove some of them because it will be very useless and very costly also in order to use all of these attributes for our machine learning algorithm. Obviously it would take time to process this huge amount of data, and some of these data might not be useful also. In fact, they will just deviate our machine learning algorithm from reaching to the good and better solution. So that is the reason we need to only get the important features for our machine learning algorithm and remove all the unimportant and unnecessary information from our data sets. So now if you talk about the correlation, so correlation can only find the important features which are numerical. So it should be numerical in order to find the important features if you are using the concept of correlation. But in our data sets, you can see some of these values are not in fact numerical, they are categorical, like this country. See here, this country is string. They are in fact categorical, they are not numerical. So we cannot just select these features if we are using correlation. So correlation can only be used for numerical features or the feature that contain numbers. So it can only work with the number, not with the categories. So in this video, that is the reason we only select the numerical features using correlation. So if we will use this data now in the upcoming video, then what we will do is we are going to make a machine learning model which will predict this thing is cancelled. So our machine learning model will predict these values. I can just fill with the different color for it. So see here, is cancelled. So this is cancelled attributes tells us whether the guest cancelled their booking or not. So our machine learning model will use this data, like these attributes, and try to predict whether, based on these attributes, if they will cancel our booking or not. So this is cancelled will be our dependent variable, and the rest of these attributes will be our independent variable. Just remember that is cancelled will be our independent variable. So is cancelled will tell us whether the booking will be cancelled or not. So is cancelled. So is cancelled will tell us if our booking will be either 0 or 1 values. So 0 represents no, the booking has not been cancelled, and 1 represent yes, the booking will be cancelled. So this is what our machine learning model will predict in the later videos. So that means this is cancelled attribute will be our dependent variable, because this is what the machine learning variable will predict. Now in order to predict this dependent variable, we will need independent variable. And what are the independent variable in our case? All the other attribute except is cancelled. So all of these, like these children, babies, and these attributes, all of these like arrival date month, all of these are our dependent variable. Now in order to check whether these attributes are important or not, we need to check if they can predict this is cancelled attribute or not. Whether this arrival date month attribute will be able to predict this is cancelled attribute or not. So basically we are checking if they are correlated or not. That means if one changes, does this value also change or not? So that is what we are going to check. Now let us go to our code and let us do that. So it is very easy in order to check the correlation. So first of all, I will take our data. If you remember, our data was final data, and I will just call this correlation function to it. And if I print this, then you will find we have these matrix like structure where we can find the attributes in either side, and this value are the correlation value. Since is cancelled will be perfectly correlated with the is cancelled, so it has a 1 value. So 1 means perfect correlation, 0 means there is a no correlation, and -1 means negative correlation. So the value of correlation ranges from -1 to +1, -1 being a perfect negative correlation, +1 is a perfect positive correlation, and 0 is no correlation. So let us store it on the some variable. Let's say correlation is the variable that I want to store to. Now what I want is, from this correlation, I don't want each and everything to be plotted, but I want to check what is the correlation of independent variable with the dependent variable. So that means we want to check what is the correlation of all these attributes with is cancelled. So we are basically checking if all the other attribute can predict is cancelled or not. So for that, let us go back. Using this is correlation, I want to only check for is cancelled. So let us say is cancelled. Now let us run this. Then you can see we got the values of each of these attributes, and these are the correlation value between these attributes and is cancelled attribute. And see here, is cancelled with itself have the perfect correlation, and that is obvious because we have is cancelled and we are checking against is cancelled, and that will have perfect correlation. So I don't want this first row, so I'll just remove it and I will just require the remaining row. So I just slice it and let us run it now. Then now we have this correlation table where we can see what is the correlation among this attribute and is cancelled attribute. So the change in, that is 29% change in is cancelled attribute can be explained by lead time. So that means lead time and is cancelled are related with this percent of values. So that means the higher the values, the better. And you can see this value ranges from -1 to +1. So basically if the value is close to 0, that means that is not an important feature. We are going to find the highest possible values, and if the values is closer to 0, then we are going to remove it, because if the value is close to 0, that means it is not perfect correlation, or basically it is not able to predict is cancelled. So let us check that which of the attributes are important and which are not. So I'll just store it in the correlation. And now from this correlation, what I'm going to do is I'm going to see the absolute value of it, because we can see some of them have negative values and some positive. So I'll just have the correlation. Maybe I can also just use this correlation and not store it in some variable, and use this absolute so that the negative sign will be removed. And I will sort it by the descending order. So I'll just say ascending should be false. That means it will sort by descending order. If I run this, then we have this sort. It should be sort values. If I run it, then we got the value in the descending order. So that means the lead time is having the highest correlation with is cancelled. So is cancelled is what we are going to predict, and this is what we are going to use to predict is cancelled. So here these attributes are having the highest values, and these are having the lower values, like children and this arrival date week number. So these are having the lower values. So maybe these attributes are not important to predict our dependent variable. So maybe we can remove some of these attributes, and we can only add these many attributes because they are important one, because they have the higher correlation value. So in this way we can select those attributes which has higher value of correlation among the dependent and independent variable. So here let us take the lead time. So lead time and is cancelled has a correlation of 0.29. So that means we have is cancelled here, let's say. So I have this dependent variable which will be used to be predict. So that is cancelled. So this should be predicted, and its value is either 0 or 1, and this needs to be predicted. And similarly we have the lead time. Let's say lead time. I'm not using all of them. I am using basically only the single attribute lead time. If we go on to our data sets also, so lead time is right here. This is the time, lead time. So basically I'm using this one, lead time, and using this lead time I'm going to predict whether the booking will be cancelled or not. So if I am using this thing to predict this, then the 29% change in the is cancelled will be defined by the lead time attribute. So what is this 29% here? So 29% is defined by this correlation. See here 0.29 is the value. If you convert it to the percent, then it will be 29%. So 29% change in this dependent variable will be explained or described by this lead time attributes. So that means this is important one. Just remember this. The higher the value, that is the better. So these attributes have the higher value, so that means they are better. They will better predict our is cancelled attribute. And these values here have the lower values. So that means this will predict that is less accurately, because they are less dependent or less that is correlated with our is cancelled attribute. So that is the reason we can see through this correlation which of the numerical features are important. Now in our case we can see, going back to our data, we can see some of these attributes are not numerical, like this country. See here, this country here is not a numerical. In fact, this country values is the categorical values. So we have these, that is categorical values. So we cannot check whether this feature is important or not through correlation. So in the case of correlation, we can only predict, that is whether the numerical feature is important or not. But in the case of categorical, we cannot do it using correlation. So that is important one. So going back to our code, we can clearly see which of the features are important and which are not using this correlation. It is just one line code. By checking it, we can find if they are correlated or not. So in the next video, we are going to check whether the categorical attributes are important or not. So that is all in this video.